Okay, so we're actually doing a little game, and this is the first question that the students are supposed to be doing. And that's what's happening. All right, so on this one, you square root both sides. You can hear the class in the back. They're talking. They're all excited about the contest. All right, and you do get 2 answers. Do not forget this tomorrow. Do not FOIL, subtract, and then refactor. You will run out of time on that question if that's the case. Okay, next question. Okay, so here's the next one. You actually have to distribute, subtract, and then refactor to get -2 and 2.5. There is no 10 product rule. This is one I think I had in the notes back in the day. So, what if you couldn't factor? What would you have to do to solve? Quadratic formula. One student listened to my question. Great. This is not algebraic, because I heard some people, it sounded like they swore. I can't believe it. All right, this has to be, actually it doesn't have to be, but do it with a graphing calculator. So you got 2 people out of 3 probably in your groups that can grab a calculator and get this figured out and double checked. All I'm looking for is, what does x equal? So it's only the x coordinate that you write as the solution. I got to zoom this back. Okay, so you just say x equals 2.66. That's all. So I'm doing the 14, no calculator, because this is one of your basic functions. You need to know what that picture looks like without a calculator. So what is the domain, and then what is the range? Why did I take your calculator away? Because this is one of the 5 basic functions. We need to know that this is a parabola facing up, and the vertex is 2, 5. So a little questionable graph over there with that group, but we'll leave it go. And it is, I heard this group say 5 with a bracket because you have to include it. It's perfect. 5 to infinity just by looking at the picture. Same thing. Find the domain and the range. I'll give a point for each. This is a 2-point question. Domain and range. Okay. Now, this one deserves a lot of looking up here. Good job on the domain. Those that got it. Remember for this picture, what are these dotted lines called? What are they called? Asymptotes. The zeros of the denominator are vertical asymptotes, interruptions in the domain. So the way you say not equal to -2 and not equal to 2 is by this long convoluted interval notation. Now I gave group, I guess we'll call you group 2 a point, because you did come up with this tough part of the range. You actually had to find this maximum right here. All right, but then what you forgot about maybe is there's a what else kind of asymptote. There's a horizontal asymptote at y equals 1. 1x squared over 1x squared, y equals 1. And you can see that in the graph. So looking at my hand, or I'll do it on here, range is what is covered for y. These values are covered for y all the way up to here. That's where the graph exists. So you have to find the maximum. That's at 1/4, and it is a bracket because that's part of the range. Then it's all these values up to the asymptote, which is 1 to infinity, not including 1 because you are approaching 1, not crossing. All right, so be aware of that for tomorrow. Same graph, just tell me where the function is increasing. What intervals is the function increasing at? So get your calculator out. Remember the points that I said were important, and then you can go from there. We had some success on this one first hour. Okay, we did have one person get this right. Remember, pay attention real quick, because obviously we have an issue with this. Look at this yellow. What's this yellow doing as I read it? It goes increasing. That's when I plug in negative infinity for x all the way up to -2, that asymptote value. But then what's this doing from here to here? Increasing. You need the x's though. So it's from -2, that asymptote, to 0 for x. I know this was 0, 1/4, but that's where it changes to go decreasing after this. And these 2 parts are decreasing. So it's negative infinity, -2, -2 to 0. That's the 2 increasing intervals. Put the pressure on. Everybody in first hour got this one right. Come on. Yes. We should listen. See that 0.9999? You see that? What did I tell you that actually is? It actually is 1. That's a calculator little error, little what do you call it? Programming problem. Okay, so it is 1, -2 for the minimum. Do be aware, look at what I wrote over here. I may get mean on the test tomorrow. The x-coordinate is where the maximum occurs, or minimum. The y-coordinate is the maximum or minimum. That's a verbiage or a word thing. Were you right? Okay. All right, so give everyone a point. And just one. Okay, so we got two groups with points. Okay, and here is the answer to this. Remember, to algebraically test, this is exactly what it looks like algebraically. You plug in a negative x for x. You don't put 1 and then negative 1 and then see what happens, because that's just one set of pairs of points that might be symmetric. When you actually plug in negative x for x, that proves that all x values have symmetry across the y-axis, and that would be even. So look at it. Make sure you do this tomorrow. I will ask algebraically. Main question, even, odd, or neither. I want the simplified answer, though, after that algebraic test. So I want it simplified correctly. I want it simplified correctly, or else no points for you. You guys. All right, here we go. Just so it looks like most of us got it. Okay, so back to answering your question. If it's even, you get no change. If it's odd, what happens? Anyone? Everything's opposite. Like all the signs change. This one, when you mathematically simplify it, which is how people simplify math, you just end up with something completely different. But I just wanted to test your negative exponent skills in order to simplify that correctly as well. Actually, the real trick is do f divided by g with what's listed, then find the domain. That's where the real points are coming from. So the real points are find the domain after you do this. Do not worry about algebraically simplifying. Just find f divided by g, then find the domain. We had one group get close enough. I tried to give them a clue, and I'll give it to them. Okay, here's the problem. If you look at the denominator, you should know x cannot equal what? What can't x equal the denominator? No, the denominator. 2 or? But then the numerator, what can't x equal? Negative. So negative 2 is already out, but I can't, it can't be anything negative. So there should be no negative number in your list. And then my question was, can you have 0 in the numerator? The answer is yes. So that's why 0 gets a bracket up to 2 and then 2 to infinity. Not including 2 because of that 0 down on the bottom. And that negative 2 is already taken out because x couldn't equal negative anyway. All right, so a little bit of a complicated domain. Obviously, the division statement's pretty easy. Find f. What is that thing? Flog of x? Yeah, go ahead. You need to know this. We said, what's the domain of the square root of x? What's the domain of that? What's the domain of that? Only what? Positives, okay? But in the progression of a f of g of x question, what's the domain of this? Just answer that question. What's the domain of that? All real numbers. Then this gets inserted into this. So now it's time to do the domain of that only. And the domain of that is, you can plug in negative 2, because then you square it, it becomes 4. 4 minus 4 is 0. Square root of that is good. And then all these other negatives work as well. So that is actually the answer. And most of you did get it. And that's good. Now we're going to find g of f of x of the same 2. And then we're going to find the domain at the end. Okay, so the domain is very well done. You have to worry about the domain in step 1. The domain in step 1 is all numbers greater than or equal to 0. So that's 0 to infinity. Even though it simplifies at the end to be all real numbers for a domain, it's still step 1 that you have to worry about. So again, it's a brackets. Okay, so we missed a couple brackets. Okay, there's actually, I think, only 2 more. This one and one more. And I should have had something more complicated. I remember seeing your homework. Your homework was actually pretty excellent on this stuff. I was really impressed with analyzing those piecewise correctly. Here it is. Sorry, frozen. Here it is, and one group got it right. I need to see your shape correctly. No, that was 1 point. Okay. You didn't get it, though, right? Okay. All right, no sneaking points up there. Okay, but you got a parabola in the green here, and you have to graph it for values less than or equal to 0. So that's why these points are off to the left of the y-axis. And then the right side of the y-axis is the line. All right? We all good on that? So, real fast speed one, boom, boom. Okay, that's one of those composed functions, but working it backwards. This group wins. All right. Okay, have a seat.